So one way to do this is to have actually voters rank the candidates. In other words, you don't really just indicate your first choice, but you, in addition to that, you also indicate your second, third, fourth choice, however many choices you want. And so that's called so the collection of methods that take that as input, these ranked ballots are called ranked choice voting methods. Okay. And in the US, they are implemented in a bunch of places. For example, the state of Maine uses the state of Alaska, and many, many cities and municipalities around the country. In fact, Boston is uh, very close to adopting and implementing ranked choice voting for its city council and mayor elections and other things. So this is what an actual ballot from Maine looks like. It's actually very simple, very easy for voters to understand, to fill out the ballot. Now, the question is, how do you then decide the winner? And there are various ways. So voters rank ballots, and then you can take those ballots and you can do various things with it. Okay, and some of the algorithms for tallying votes go back to the 13th century, uh, and although they carry names of people who lived later, but this has been studied and considered for many centuries. So one most common algorithm to tally ranked votes is something called instant runoff or Hare's method. So basically, what happens is if nobody has majority of the votes outright, right at the beginning, right when you look at all the ballots, nobody has won more than 50% of first place votes. So what you do then is you take the candidate with the least number of first place votes, you eliminate them, and you pass down their votes to the second choice of the voters who had that candidate as the first choice. And now you retabulate. Now you see who now has most first place votes. And if nobody has crosses the 50% threshold, you repeat again. You eliminate and you retabulate or reallocate votes. So let me just give you a quick sort of pictorial example. So for example, here are four candidates, and they have after the round, you look at the profile. Profile is the collection of all the ballots. It's the election, right? So you look at a profile and you see nobody has 150% of votes, but candidate D has the least number of first place votes. So they're going to get eliminated. And we look at the ballots that had D as first place. We look at the second place on those ballots. And we now give those ballots to the second place people. So something like this might happen. A little bit of those D voters had A as a second choice. So we give A those votes. And a bunch of them had B as their second choice. So B gets those votes now. So this is the reallocation, redistribution step. Nobody has 50% yet. So you do this again, and now you are eliminating candidate C because now they have the least number of first place votes, and maybe something like this happens. Maybe more of those C voters have B as the second choice. So B now gets those votes, and they cross the 50% threshold, and they are the winner. Notice if I ran plurality election on this in this little example, A would have been the winner, right? Because A initially had the most votes, 40%. But instant runoff does something different. It really is taking more information into account and sort of it has this iterative approach to reallocating and tallying votes. Instant runoff, as do a couple of other methods I'll mention, all pretty much eliminate spoiler and spoiler effect and vote splitting. Not completely, but they do for the most part. For most actual elections, what you will see is this would not be a problem. There's other ways to tally ranked votes. If I give you a ballot that has rankings, first candidate, second, third, fourth, you can assign points to them. So if you have an N candidates on a ballot, the first person on each ballot gets N minus one votes, then N minus two, N minus three, etc., down to zero. So if I have five candidates and I see a ballot that ranks them A, B, C, D, I give A 4 points, B 3, 2, 1, 0. And then you look across all the ballots, and add up the points, and whoever has the most points wins. This is a very familiar system. Anytime you assign points to any kind of rankings, like we just had the World Cup, right? At the group stage, you're assigning points to wins and losses and ties, and then the teams with the most points advance to the elimination stage, right? Then there's a third, so that was called the Borda count. Borda and this guy Condorcet were contemporaries in France during the French Revolution, late 18th century. And Condorcet didn't quite like this method because it has it has a few flaws, and he introduced a different method. He said, well, let's look at pairwise comparisons. Let's look at all the ballots and take two candidates, A and B, and see how many people placed A over B and how many people placed B over A, some in their ballots. And then whoever wins that's the winner of that pairwise comparison. Now, do that for every possible pair of candidates. So you have winners of all the pairwise contests. If there's a candidate who wins all of their head-to-head contests, it beats everybody else in these one-on-one competitions. That's the overall winner. That's who we're going to call the winner of the election. So those are just three of the methods with which you can tally ranked votes: the instant runoff, Borda, and Condorcet methods. And there are many others. I'll mention some in a second, but here's what's interesting now, from the mathematical point of view, at least. I won't go through this, but for example, this is an example where the following thing can happen. So the way you're supposed to look at this table is column by column. So what this means is that 36 people have turned in a ballot that says A is ranked first, then D, then E, then C, then B. 24 people have the rankings B, E, D, C, A, and so on. So this is a manufactured example to illustrate the following thing. There is no majority winner in this election. If you look at the first place votes, right? So you're looking at the top row. Nobody has more than half. I think there's like 110 voters here. So nobody has 56, half or more. Plurality winner would be A. They have 36 first place votes. That's more than anybody else. So they would win this plurality election. If you do the runoff, which you can also calculate the runoff from this data. There is enough data there to see who would win the runoff. Actually, B would be the runoff winner. If you did instant runoff on this, C would be the winner. You could probably see where this is going, right? If you do the Borda count, the point allocation, D would be the winner. And finally, if you do the head-to-head comparisons, the Condorcet method, E would be the winner. All right. So this is, from an academic point of view, this is very exciting because voting seems to be interesting. It's doing interesting things, right? To the same election, basically. It's declaring different winners. It has a way to think about it is like math kind of focuses on different things. It prioritizes different things about the ballots. If you are someone who's trying to implement voting reform somewhere in your town or country or state or something, this is a nightmare because it would be nice from that point of view if all these methods agreed and always produce the same winner. Then you don't have to worry about it. Just use any of them, and you don't have to worry who the winner is. But the big question now becomes is, well, what's the best possible method that we should be using out in the real world, right? What should the democracy reformers and democracy practitioners, what should they advocate for? What should they get out there and try to push instead of plurality? So everybody agrees that plurality is bad, we shouldn't use it. But then which of these methods do we use instead? And this is just the beginning of the story. There are lots of other methods, both for ranked choice ballots. Then there are methods that don't even depend on rankings at all. They don't ask you to rank the candidates. They just ask you to evaluate each candidate kind of separately. Then you can have elections where more than one winner are elected, like you're electing a committee or a council or something. So there's a slew of methods. Then there are proportional representation methods. You use DONT method in Bolivia, I believe, to to again elect a slate of candidates, but trying to keep proportionality in mind, etc. So the list just goes on, and what's what's worse is that these methods not only can they produce different winners, but they can actually exhibit strange behaviors. So I want to give you a fun example. It's also a classic example that everybody cites in all the books on voting theory, and that is the 1995 figure skating world championship. All right. So back then, to score the performers, they used a version of the board account, the point assigning method. So Michelle Kwan was the teenage rising U.S. skating star, and before she skated, this was the this was the ranking who was in first, second, and third place. Then she skated, Michelle Kwan skated, and this is what happened. I'll give you a second uh, to sort of to look at this and see what's strange about this, right? So Michelle Kwan skated and came in fourth. Okay. But look at the second and the third place. The second and the third place flipped, right? So this was a big scandal. This was really strange. And mathematically, it's not strange. Board account can do this. It fails something called independence of irrelevant alternatives. And what can happen is that if you take the ballots and you look at a candidate, but then you move stuff around that has nothing to do with this candidate, right? Somehow you mess with the ballots in a way that doesn't affect, shouldn't affect this candidate, but board account penalizes this. If this candidate was the winner before, you can do stuff away from that candidate and cause them to lose. So that's one of the strange sort of paradoxes of voting. Okay. So this is part of the reason why this subject is academically interesting, and it's what's called social choice theory. It belongs in, it lives in the intersection of fields, obviously because it touches so many of you know uh, so many aspects of democracy. Uh, but its home is kind of in economics, really in game theory in economics. I'm sure you know more about that than me probably. So this is basically an axiomatic framework to study the aggregation of individual preferences into collective decision. How can we as a group express preference and then come up with an outcome that's beneficial to most of us somehow, or as many of us as possible? Is the process sort of democratic, representative? Do we have some kind of ranking in mind according to social welfare or social well-being that we would like our method to reflect? So that's what social choice theory is. And what social choice theory has done is it has looked at various electoral methods and discovered all these strange behaviors and properties. And then, as any kind of formal theory starts, it sets out axioms based on that, on the examples, axioms that sort of a good aggregation rule or a good voting system might satisfy. So now there's like, a list of dozens of these things that we like to see in a voting system. For example, there's something called the Condorcet criterion, which comes right of the Condorcet voting method. If the candidate beats everyone head to head, they should be the winner. Okay, that might be something that you impose on your voting method as a rule, as a property, as an axiom, and then you can test whether your voting method satisfies the Condorcet criterion or not.